All right, welcome back everyone to the Cyberbot Educator Workshop, day 3 in the April 2022 edition. As always, or as during the last 3 sessions, this is your link to the slideshow. Say, Stephanie, would you be able to copy and repaste that? I pasted it in before everybody got here, so they probably didn't see it.
Yes, I will do that.
Now, before we get to the infrared testing and navigation, I just wanted to mention that we have a upcoming course. This is going to be starting the week of April 25th. It'll be Monday, Wednesday, and Friday, but it starts at 3 p.m. Pacific and goes to 4:30 p.m. Pacific. We thought we'd test that. And that reminds me of something to ask you all about. This workshop is with the Microbit, but the emphasis is on electronics. So this is actually the current version of the textbook. I'll paste that in. You can browse through it if you like. I'll show you just a couple things really quickly. First of all, because adding a circuit emphasis to the workshop is a little bit more challenging, we also added extra visual support in the form of GIF images, and then even extra large versions as MP4s. So like, for example, when we run it for our students, we have a nice MP4 that you can also stop at certain steps and then continue as you're following the instructions. This book is somewhat more science oriented. For example, this is in the Ohm's law section where we equate voltage to current and resistance in a circuit. And as you can see, we actually have a little virtual whiteboard where we go through solving an equation to, in this case, solve for current given voltage and resistance. Here's another example. This one is emphasizing what's going on in the Microbit and how its microcontroller is actually making an electrical connection to 3 volts to make a light turn on and 0 volts or ground to make the light turn off. And it's also associating the code for blinking a light on and off with the actions inside the Microbit, what the circuit looks like when that happens, and then what the eventual effect is on the light. We also have push buttons, which gets a similar treatment, though I didn't add it here. This is an example of servos, and instead of just kind of doing a hand wave on the signaling, we actually look much closer at the signaling. So at the beginning of the chapter, as an example, it shows you, hey, here's the different pulse widths that are applied to the servo. And then later on, we have a virtual oscilloscope. Well, it's not actually virtual, it's a real oscilloscope. The Microbit takes lots of measurements and streams them to an oscilloscope application so that the students can actually measure those pulses and see how they relate to the servo's motion. So this is it's a much deeper dive, and if any of you are interested in if any of you think that might end up being a good fit for one or more of your classes, please do apply. Last chance, apply today, because it closed yesterday technically, but we're going to let since I didn't think to mention it on Wednesday, we'll go ahead and let you in if you apply today. And hopefully with the later start time of 3 p.m. Pacific, it won't be necessarily as much of a challenge for scheduling a sub or anything like that.
I see in the chats, people have said, I replied but haven't received a response yet. Well, I just sent out responses just before the course. And so if you had already applied and are in this course now, you were accepted in. So this is just for anyone who wasn't aware or who's decided they'd like a deeper dive or to use this kit as a complement to the Cyberbot itself. So it's a last chance if you could pop on over there and thank you for putting Andy, that link. I already took it down since it's closed to the public.
Oh,
So well, that link is still there, but it no longer connects to the forum. I'll paste the forum link in here.
okay. Sorry, folks. That link
That's
I
okay.
just pasted in is no good.
Yeah, I pasted in the link to the actual forum because it's closed to everyone else. Just this is a last chance invite for you folks to see if there's any more takers. So if you would just go ahead and do that, you know, sometime during the class or shortly after the end. And if you're not sure you can make it, you have to like get approval or something like that. Go ahead and sign up. And if you would cancel by end of the day Monday, if it turns out you can't make it, that's what I'm asking of everyone. So thanks. End of commercial.
Okay, so today we are going to finish off the infrared navigation, then look at the cybersecurity lessons, an overview of some of the projects you can do with additional parts that are available for the Cyberbot, and a walk through some of the available educational and product resources. I'm actually, I think, going to put this cybersecurity lesson overview at the end because that might go long. And so if folks want to hang around and talk a little bit more about what's in there, that'll work out nicely. Okay, so on to this. So this is where we left off was, okay, for your homework, let's build and test this circuit. How did that go, everyone? Does everybody have a working circuit? I'm getting some thumbs up. Okay. All right, so what we wanted to have at the end of this is so here's our Cyberbot. Let me zoom in on it just a bit. There we go. And then back it up just a bit so you can see my hand in front of it. All right, so when you loaded your code, what we wanted to see was these two lights in the lower corner. Let me do this like we're normally working on it. Okay, so we'd want these two lights in the lower corner to both be on when the infrared LED flashlights are shining their blinking lights off into eternity. Now, when you put your hand in front of the right light, we want the P21 light to go off, then back on when you take your hand away. If you put your hand in front of the if you put your hand in front of the left light, we want the P20 light to go out. And if you put your hand in front of both infrared detectors, we want both lights to go out. So if you've got that, you're ready for some navigation.
Andy, I had a question.
Yes.
Was I supposed to, I left them on and it works okay, but I left the whiskers on and the other things that we set up from lesson 2. Is that okay, or should they have been taken off?
Well, the plan was to take them off, but I didn't mention that. Sorry about that.
Okay, and I left early at the end, so I didn't know if you told us to do that. So that's why I was asking.
What I would recommend doing is, all right, let me show you something. When you've got a whisker on, Okay, when there's a whisker on, if it runs into something, I'll turn the power off for this demo. If it runs into something, the whisker could bump against the leads here and actually connect power to ground. It could actually create a short circuit because the leads going into this part right here. Do you see how the leads are coming in and how a whisker?
Yeah, I noticed mine was doing that. That's why I was asking.
Yeah, that could end up doing
I
some
didn't have a
damage.
short circuit, but I was just making sure. Okay.
Now, sometimes it's advantageous to have both the whiskers. I mean, it's a great project to have both the whiskers and the infrared on there. The main thing to do is to take some electrical tape and wrap this part of the whisker. Now, not to the point where it's supposed to be touching the 3-pin headers, but wrap any part of the whisker that might touch other circuits that they're not supposed to touch.
That
Good
makes
enough?
sense. Yeah,
Okay.
that makes perfect sense. Thank you.
Oh yeah, sure thing. Thanks for asking. That's a great question. All right, so on the navigation front, there's Finder. The first script, the first script we actually run is one where it behaves exactly like the whiskers, and I'll leave that one to you. We again have to kind of do a topical treatment of this given the time constraints. So we're going to fast IR roaming, and I'll paste this script in a second, and hopefully it all comes through. Stephanie, could you verify that the else forward appears when I chat it to everybody? Let's see, looking for the chat. Paste.
Yep, all the way down to else forward, indentation is intact.
All right.
We did have a question. Andy, how should sensors and IRs be placed?
How should sensors and IRs be placed? Let's see here. Trying to figure out how to answer that question. Well, as shown here, I normally send the infrared LEDs a little bit off center, so they're not going. I mean, you can go straight ahead, that's fine, but it's easier to see an object. If you go too wide, you're going to have a blind spot in the middle. If you go too narrow, you might end up not seeing something that's right up against you. And also, I should mention that if you have something that is a black surface that's absorbent of infrared black plastic and black cove base and things of that nature, they won't necessarily be seen by the infrared detectors. So that's why other detectors like the whiskers can be added as a backup. And that's a nice robotics lesson on redundant subsystems. And a nice project for students. Let's see here. In terms of up or down, I have them level, looking for a way to, I have them level, basically level with the ground. They're not really pointing up or down. They're just pointing straight ahead. So that is how I have the infrared sensors mounted. Did that answer the question? Looking to the chat.
Mark says yes.
Okay, excellent. All right. Keep on jumping in with questions, folks. You can also unmute yourself if you prefer to. So fast IR navigation, we went ahead and pasted it in. So what's going to happen? Fortunately, it's slowed down a little bit. It doesn't go that fast, but you can increase the speeds to make it go faster. And incidentally, as with the majority of the things that have been on the slides, it has a link to where it is in the tutorial. And as you can see, there's other items. There's kind of a general talk about infrared light signals and how they were in a TV remote. Some of you might have noticed that, or I think I talked about some of that. And here today is a TV remote that I will point at the camera and then press and hold a button. And then hopefully that flicker is visible. So that is infrared being detected by the document camera. All right, so once you've loaded this in, so connect, flash. And then you can unplug the USB if you want, or just leave it connected. I'll zoom out here so that we can. So as it goes, it'll, I better put this on the floor. So as the Cyberbot roams, it will see an obstacle in front of it and turn away from it. Was that visible, Stephanie?
Mm-hmm.
Okay. So go ahead and try that, everyone.
We have a question. It says, looks like the sensors are straight ahead. And that was an observation. And from Mark.
Okay.
Edwin says, any way to use a microbit button A to stop the scripts on the parallax board. And Joe chimed in with, you could probably change the while true to something like while button not pressed to look into that.
Yeah.
And not everyone is having success with collision avoidance. So perhaps some troubleshooting might be needed.
Okay, so for the troubleshooting, we want to go back to the test script. I'll paste that in momentarily. Test both IR and indicators. So it has to pass the tests for the light coming on before we can expect it to navigate and avoid obstacles. So there's the test both IR and indicators script in the chat.
Sorry, I'm not looking to hijack or anything, but my bot passed both the tests, like the left and right test, so it's passing both of them.
Yes.
But with running the movement script, it's not dodging obstacles, it just plows right into them.
Huh. I'll be darned. Okay, so let's take a look at the color code on the resistor that's connected to P1. Is the color code either red, black, red, or red, black, or brown, black, red?
It's red, black, red.
Okay, let's, if you put your hand close in front of the infrared light, does it, how far away can you place your hand from the infrared light and still have the indicator light stay off? So looking at this, I'll move the robot off to the side there. And then as I bring my hand in, it's about, okay, it goes off at about, the light starts flickering at about 8 inches. See that? I don't know if the light flickering is visible in the, and then as I get to 6 inches, it stays off. So let's, okay, yours is about the same. All right, then.
For whatever reason, the The P20 light goes off before the P21, but it's only a difference of about a half of an inch or so.
Yeah, that's great. And so you're seeing that at about 6 inches, both lights will stay off.
Yeah.
Okay, but it still plows into, okay, so let me think. Let's bring that script back up. Okay, so fast IR roaming. Let's try making it turn in place. So I'll change this script a little bit. Okay, so that's turn right. And then this is turn left. Okay, so I just made it turn more drastically. Let's see if that helps in terms of obstacle avoidance. Here's the modified script. So now as it goes ahead, it definitely turns, and this is an actual obstacle. Let's see here. So here is the cycle box. Okay, any luck?
No, it still plows straight ahead. We can hold off and try and troubleshoot later.
Okay, yes, let's do that. Sorry about that. I try to make sure that everybody's experience can be positive during the actual workshop. But let's at least make sure that we've got you running. That there's one other thing that comes to mind, which is possible does it just plows forward into the obstacle? It doesn't willy-nilly turn away from obstacles that aren't there. Is that correct?
Yeah, that's correct. You just go straight ahead.
All right. Okay, I'll background process that one. Anyway, so back to the thing we were talking about, which was essentially there's some additional, I'm doing the highlights. So we did avoid obstacles and then faster IR navigation. So avoid obstacles is a script that just behaves like the whiskers. It does a predetermined turn when it detects an object. Then the faster IR navigation is, okay, I have one more thing for you, David. Make sure that script has actually loaded and that it's not a forward script. Just in case, try reloading that infrared script, the fast IR roaming. Try reloading it into the microbit. That's one possible thing, is if it was just oh, and the other thing is to make sure that you have copied and pasted the entire script. I don't know if that's going to help, but those two things just came to mind. There's also a drop-off detection script. And then for those of you for whom the infrared avoidance script is working, I also wrote you a nice little script that does following of objects, but without any tuning. There is also a tuning version, but here it is, IR following Cyberbot. And I should call it that. Coming to the chat in just a moment. There it is. So this is the IR following Cyberbot. And I'll show you how it should behave. Essentially what it should do is it should follow your hand. I'd better maximize this this window here so you can see what I'm doing. See how it's maintaining a distance from my hand? I can push it backward or take it away and it follows forward. I can even change the angle and the robot changes its angle to continue basically maintaining a distance at the target I'm presenting it with. Are we having any success with that one?
There's a number of people who are having various different type of difficulties. Why don't we see how many people have this working, and then we'll know the scale of troubleshooting needed.
Yeah, okay, so I'm seeing 2 thumbs up. And David picked an excellent emoji for that. Sorry,
Oh.
David.
Okay. Well, if we do troubleshooting after the fact, but leave time for it so more people can participate, at least it will be a good example of what troubleshooting possibilities might come up for students.
Yeah. Yeah, that's kind of an unusual one though. I'm not, I'm drawing a blank as to what could be going on there.
I have 3 workings right now.
Could it be that they forgot to put in the script Cyberbot module file? Because I had an issue with that, so I was just offering. Sorry, David, I just was asking.
No, it's a good piece of advice. The reason I didn't suggest that is because without the Cyberbot module, what would happen is you'd simply see an error start to display across
Right.
the Microbit's 5x5 LED matrix without any motion at all. So because of the fact that it's moving forward, I was thinking, well, gee, maybe there's just a moving forward script that's running. The other thing that seems possible, and this actually brings up a subject I wanted to talk with you about anyway, is let's take a look at, okay, so here's a battery pack that's outside the robot, and I'd like you to watch what happens. I lost my pointer, sorry, folks. Okay, I'd like you to watch what happens up here when I knock one of the batteries partway out of the holder. So I took one of the batteries partway out of the holder, and see, now we have a battery voltage problem indicator. Now this is going to warn you when your batteries are running too low And it'll also warn you if one of the batteries popped out of the case. When you correct the problem, it's still going to go for another 10 seconds. And then it'll turn off. So just wanted to let you know about that low battery indicator. That's one of the features of the board. And so if you load a program and it doesn't seem to be doing what it's supposed to, and you're getting a low battery indicator, as I was just then, and I think I had to wiggle the barrel jack a little bit. Anyway, that's a thing to keep your eye on. And what else do we have? Okay, how many people, Stephanie, have confirmed through the chat that they've got their application working?
4, 5, 6, 7.
And there's some more coming in. Good, good.
8, 9. Okay, don't wait on my account.
Thanks.
Okay.
Hey, that's
10.
a lot of thumbs up. And that now, is
Yeah.
this for the following application? Have you all got it following your hand, and you can say that the force is strong in me now?
Mm. We do
Okay.
just have a couple still. So
Well, I think that we'd better schedule that troubleshooting for after the session.
mhm.
How many? Well, I mean, unless actually, if anybody wants to unmute and just describe your symptoms, I may be able to tell you straight off the bat what I think the problem might be.
Monica was also having a difficulty.
Thank you, Stephanie. I was gonna wait till later, but I
Oh.
try to do, no, it's fine. You're
How did
fine.
you?
I didn't want to take over. No, the following program that I just loaded, all the robot is doing is going backwards. So I don't think that maybe I did what I was supposed to do completely with the infrared sensors. That may
Oh.
be because the other one didn't, the previous one didn't work either.
Okay.
You know, trying to navigate. So I'm not sure, because when I try to run the test program, only the 20, the 21 light turned on, not the 20.
Okay. So
So
if the 21 light stayed on, now did the 21 light go off when
No.
you put your hand in front of either of them?
no.
Okay. So let's see here.
And when I turn
Time-wise.
off, right, I set my robot to 0. There's like the red light, like a warning light blinking. just
Okay,
in
so
case that-
that's the low battery light.
Oh, good. Okay.
So for the low battery light, make sure that your barrel jack is well plugged in,
Okay.
and then make sure that your batteries are well plugged in, and also that their polarity is
Yeah, I have those under control because I had them drop out a couple of days ago. So.
okay. Yeah, and then another thing is if the battery is left plugged in, I think that can end up draining it, especially if you have the power on. That will
I've been playing with it a lot, so maybe that's probably why.
Yeah, that could be. That could be. All right. Anybody else?
When I touch the resistor going to P3, then P21 blinks. The sensor
Okay,
does
so
not work.
that is probably a resistor lead that's not plugged all the way in. This particular circuit is one that really has to be exactly right. Every resistor plugged in, each resistor the correct value, and then it passes the test. And essentially, this is the kind of activity where the students will have to go back to the drawing board multiple times to make sure that they pass the test. And David, this is the first time I've heard of the test passing, or that I can remember the test passing, yet it seems blind when the motors are running. So we'll want to try to figure out why that's happening.
If it just scrolls a message and nothing else, that's a problem in the code, or perhaps not loading your Cyberbot.
Yeah,
.py.
if it just scrolls a message and does nothing else, the load save show files, you might not have a file open that has cyberbot.py in it.
Mhm.
And so to do that, you'll want to, like, I'll go ahead and delete it here. And then we want to add a file and then go hunting for the cyberbot MicroPython folder. And then you'll see cyberbot.py. Alternatively, you can open the, so that'll add cyberbot.py to it. So again, hit load save. And then check and show files to see if you have cyberbot.py added to your project. I see a question in there about teaching at the community college level. I'll try to pick that up in a minute. Okay. Let's just talk about some of just a few obligatory things that I want to make sure to get out of the way before going into cybersecurity and then also doing the troubleshooting. So for projects, there are some projects available. So if we go to learn.parallax.com and then go to the Cyberbot book cover, I consider this to be an entire textbook because there's quite a bit of material here. There are projects, and these projects use optional add-ons that can be purchased and added to the Cyberbot. One of those projects is the QTI Line Follower, and it's for small infrared sensors that you can attach to the chassis, and it can monitor for a black electrical tape stripe to follow various courses. Since these are the infrared, since the infrared receivers, the small black boxes that you put on your breadboard, are in fact the very parts that are inside old television sets that use infrared remotes, when you point an infrared remote at it, it will transfer all the information that the infrared remote sends to the microbit. And as such, we have a project. So control your Cyberbot with an infrared remote. So they're pressing 2 to make it go straight and 4 to have it go left. And each of the number keys give you a different maneuver, including 5, which will stop it. Students seem to really like the remote controlled bot. Back to the QTIs, that also is linked on the little tile. And so this is the QTI project for the Cyberbot. And it goes through very carefully on installation and wiring. And then, as is the pattern with the rest of the circuits, we have a test program first. And this test program, you put the stripe under each different QTI sensor, and then you will see a different stripe shown on the microbit's display. And after that, there's a example program that uses that you can try out and expand for competitions and stuff like that. Last but not least, there's a rotating ultrasonic distance. There's a distance sensor, an ultrasonic distance sensor on a rotating turret. And that's a pretty cool project. And here we are using the ultrasound to roam. It just saw a wall and it just turned away from the camera. And so it sweeps back and forth, which is really good for even escaping corners because it can see where not to go. There's, I said last but not least, but that's because I forgot about the gripper. It's a popular add-on. This is a different robot chassis, but it works the same on all the different small robots. It's a different control board on top, but it works the same regardless of whether you have that control board or the Cyberbot one. That last one was an application that we don't have for the Cyberbot that I'm aware of. So I stopped the video. It's a color recognition thing that can be done with the propeller activity board and the Arduino version of the robot, but not with this one. At this point, might try to get that running. Next up is educational resources. This is this page is a repeat from day one. This is the links that we have used during the workshop. Again, there's student resources and teacher resources. For student resources, I think I want to show you how to get there from the beginning. So again, it's learn.parallax.com and then just find Cyberbot. And that will take you to the first page or the table of contents for our web book here for the Cyberbot. Now, if you're an educator, go to the Educators tab up top, and then there will be Cyberbot resources. There's a fair amount of resources that are just available to the public. For example, we have a teaching strategy guide, and that brings us back to the question of teaching at the community college level. So there's there's some strategy and assessment grading guides here, as well as I don't see that. Okay, so as well as a scope and sequence guide. And the scope and sequence guide.
You're in Activity Bot.
Oh, weird. I don't know.
There might be an inaccurate cross link.
Yeah.
There is a the scope and sequence should be right there, fourth under downloads.
There it is. Thank you.
And we actually do have have all of them. That's a download, but there's also somewhere all in a Google spreadsheet that has a tab for each of the robots.
Yeah, so this shows a PDF printout of that spreadsheet with some recommendations on teaching it at the high school level, with some nice teacher notes.
It also describes which activities in that scope and sequence are covered by the robot kit itself. And if you have a 12-pack plus, which includes a lot of accessories and add-ons, it shows what additional lessons you can do there for convenience. That's the purple across the top. That's the purple bar. That's if you have the 12-pack plus. You can do those additional 3 units on the end. And then the beige bar is just what's in the base kit, I believe. Yes, thank you for zooming in. That's trust my memory there. And then it shows you if you just wanted to do one of the additional, one or two of the additional units, which accessory you would need to get separately. One of the advantages of the 12 pack is it also includes rechargeable batteries and chargers, 2 sets of batteries. So there's always a set to go in the robots and another set to be on the chargers. So you're never without batteries for class.
I probably should have put that before the projects maybe. So Stephanie is referring to,
We were getting questions. So
yeah, Stephanie is referring to this 12 pack right here. And all of those, well, with the exception of the gripper, all the other add-on applications, the projects that I just showed you, that being the TV remote, the QTI line follower, and the turret mechanism for the ultrasound, plus rechargeable batteries and a battery recharge and battery rechargers, all come in this 12 pack. We also have standards alignment with common standards. For the sake of,
oh, here's a good question. Is it necessary to import both the Microbit library and the Cyberbot library?
the Cyberbot library imports the Microbit library. But yeah, that's kind of a two-way thing. All right. So
I was looking at the, can I just ask a question, please?
yes.
I noticed that Cyberbot ports Microbit. If I don't explicit import Microbit, the Microbit, I get an error when I try to flash the code. So I have to have 2 lines in my code. I have to import the Microbit library and import the Cyberbot library. Do you hear me? I don't know.
Yes.
I think my connection is breaking up a little bit.
Yes, it is hard to hear you, but what I heard you say is basically that for you, if you don't have that additional line, that none of your scripts work. Is that correct?
Yes.
Okay.
You know, so I'm sure if I would, because I'm reading the manual online, the only thing I have, look for bot library, see that at the top of their, it imports the Microbit.
Yeah, so on my end, if I do something that is Microbit centric, like and flash that.
Andy, I think it should be displayed.
Instead of this poly, like so. There we go. So we have the hello. So on my end, it does not require an explicit from Microbit import. So one thing that comes to mind as a possible reason for that, and you can look at this by taking a look at your script in the alpha editor. So instead of python.microbit.org/v/2, you can change that 2 to alpha. You're going to save your work before you do this. Then change V2 to V alpha. And you will get a different looking editor. Now, what you can do then is take your script that, see, test both IR indicators. So what you can do is open your script in this editor. And now this is the test IR indicators one. And then you can look at the project files. That's this tab along the left here. And select cyberbot.py. Instead of your main file, select cyberbot.py, and then look and see if it's version 0.9.2. And notice also that the first thing in the module is that it imports the microbit files. And as a result, you can normally, after importing from Cyberbot, you can normally do a microbit centric thing because you have access to the microbit. Oh boy, I just signed up for some delays.
Okay, thank you.
Certainly. There is another issue, which is I want to remind everybody that if you're trying to do a microbit only thing, I'm going to come back to this. So a little bit more on the, so here are the common standards along with the entries within each standard that you can align with the Cyberbot curriculum. And then notice that because I'm not logged in, it shows that that I can't get to the student questions and solutions, or the questions and solutions that are held for students. But if we log in, and then refresh this page, now instead of being locked away, we have access to the assessment material. Where'd it go? Which looks like this. And so for each one of these, like I'll go ahead and download navigation. So here is the assessment material for that chapter, and it's both in RTF for Microsoft Word and then a PDF format, which is opening in another window. And this was the navigation chapter. And so here we have some assignable items for students. They make nice worksheets. Just make sure not to print beyond page 3 where you start seeing the red stuff, because those are the solutions that we intend you only to be able to access as teachers.
So we have some more questions about how longish does a full course take? A semester, 12 weeks? And then also would CTE apply to community college level?
I don't know. The community colleges essentially use the small robots to fulfill curricular check marks, but I don't think that the standards alignment that we have published applies. I think that's up through 12 and not community college. However, there's quite a number of checkboxes for various, it also depends. Are you teaching this in an electronics class? Are you teaching this in a computer science class? Each of those classes is going to have its own goals, and certain items within these lessons are going to be applicable to those goals. Going back to this, not the scope and sequence, the standards matrix. So yeah, I think you'll have to do some side by side with each document to see what's going to, and yeah, I would focus on the CTE standards. And I think you'll be able to find a number of them that cross over. Well, I mean, look at all the standards and you'll be able to find a number of them that cross over with the goals for the particular class that you are teaching. Also, simply going through the material will most community college instructors that I've spoken with have basically gone through the material and said, okay, this particular lesson it is one of the curricular check boxes in my class. And so it might be somewhere in writing microbit programs, for example, when we talk about if-then statements, or if else if, or if elif else statements in Python, that is a conditional, that would be under the conditionals category in a computer science or a programming class where Python is involved. And so as a community college instructor, as far as I know, the majority of the community college instructors that have been using this material go through the material and then they pick what they want their students to do in the labs and as homework. And that's going to be according to the class that they're in. Sometimes it's used as an electronics introduction, other times in the robotics class, and then also in computer science and programming. Now let's see how my, so what I did was I added this display.scroll hello. And so it's scrolling hello. And then the lights came on and it's still doing the test for the infrared. And that's all just with from Cyberbot import star. Now, the other thing though, is you want to be careful not to try to do this. Oh, maybe that's what's going on. Maybe your microbit isn't all the way plugged in, because if your microbit is not plugged in and you want to do a microbit only thing, but you instead have from Cyberbot import star, watch what happens now. I'll press and release the reset button. And it is waiting and waiting and waiting and waiting. So this is the reverse of, it's waiting to establish communication with the Cyberbot. So in this case, if you had a microbit centric project where you're not in the Cyberbot, then you absolutely don't want to import Cyberbot because it's going to wait to establish communication. So here you would say from Microbit, import star. But also you would have to remove any code that uses the Cyberbot. And then it's back to working again. So there's two different things. Oh, why is it unhappy now? Oh, yeah, look at that. I didn't comment out. Well, I'm just gonna delete all the code right now. Oh, there we go. It didn't change color, but see, I have 3 apostrophes, and that's supposed to be a block comment. And then the ending apostrophes are down here, but it auto-filled 3 more apostrophes. So this was still part of the program. So if we flash it again, line 6, huh? Yeah, I think I'm going to have to chalk that up to this being the alpha editor, because that should have worked. Flash. Okay. So for some reason, the alpha editor's block comments are not working. That would be 3 apostrophes or 3 quotes. And going back to the regular editor. But again, if you're in the alpha editor, check for the most recent, that's Cyberbot at 0.9.2 is going to be the most recent Cyberbot module. And now going back to V2. And I'm going to get this back to its slow flash sequence, because the 2 different editors both take longer on the first try. All right, so where were we? We were talking about educational resources.
And we have a question along those lines, if I may jump in.
Okay.
One is, if we purchase the product, would that be okay to integrate into D2L courseware? So our copyright for our educational material is that it is used only to be for teaching with the hardware that we create and sell. So if you were to use this material in an online course, it would need to be with the students using that same hardware that the material was developed for. And the other stipulation is that you do not charge the student for reproduction of the content itself, which in this case, since it's delivered online, that's and is accessible, you know, our actual tutorials are accessible online. That isn't the same as if it was a printed book. If you were talking about incorporating the assessment material into that, yes, people do that to help deliver the assessments to their courses. We would just ask that it remains secure. The answers remain secure and not directly accessible to the students, so we can not have it spoiled for the other users. Does that answer?
Yeah, we
question,
wouldn't
Mark?
want the students to do an internet search to find all their solutions.
Yep. Okay. Yep. And so that's what we'd like to put out there.
So another question that frequently comes up is, what can I do to get the students started with the Microbit before jumping into the Cyberbot? And my best answer to that to date is that is to go and check out this YouTube video. I'll go ahead and paste it into the chat. This YouTube video covers the majority of what both microbit.org and Microsoft have done for lessons for the Microbit. And it's really quite extensive. I guess I'll open this and risk the YouTube advertisement. Oh, how funny. They didn't do an advertisement this time.
Great.
So we go into a lot of different different items here. So here is the block-based programming for the Microbit. Here is the simulator that allows you to do some Microbit only functions and actually simulate what the block-based program will do. That block-based program can be also repeated in a version of Microsoft Python that's somewhat different from the one we've been using, and also in JavaScript as one example. And then going through here, looking for some other interesting example. Well, suffice to say, here we go. So this is the Microbit classroom. And you can actually do a virtual classroom where you share out a script, and then you can see how your students are progressing as they change their script to meet some kind of goal. And so we went step by step through joining the classroom, and then sending it to the students using the online block-based stuff. So I also did talk about the Make It Code It site in here, although I can't necessarily, I can't find that spot in the video right away, but I have a few links from the Make It Code It site. So this is microbit.org/projects/Make It Code It. And one of my favorites is the step counter. It uses the accelerometer, and that's built into the Microbit. And the thing you want to look out for is select Python here, and you can even open it. You can even open that code automatically into your editor. And if you run this code, I'll paste this in. It's kind of fun because basically
we have a question. How does the tutorial relate to Microbit JavaScript?
Our tutorial does not relate it. So there are a number of Microbit only tutorials that are available on, let's see if I can get to it. Let's makeitcodeit.microbit.org. I'll give you that
So
link.
just making people aware it's an alternative resource.
Yeah, let's see, Make It Code It. Oh, wait. Well, that took us straight to it, but it's also in that list of links. So when you're in Make It Code It, what you can do is you can filter for example, for projects that use make code blocks or projects that use Python. They even have Scratch in there. I don't know why I'm not really seeing JavaScript. If we go to Beating Heart, I know that you can open it and make code.
And then see the JavaScript.
Yeah, and then you essentially have options of editing the blocks or editing the JavaScript. So there's the JavaScript of it. And you can also edit Microsoft's version of Python, which is somewhat different from the one we've been using here. So both Microsoft and BBC have their own separate versions of Python. They're all technically Python, but the implementation and the way it looks and feels to use is somewhat different. So I do not know off the top of my head where tutorials would be. I'll have to look for that and if you could email me a request for that, I will see what I can find. So running this script, okay, right now we're showing a 9. I just shook the, oh, I'm sorry, it was a 6. Okay, so now we're showing an 8. And each time I shake it, I should get a new value. So there's 10, 11, 12. I'll restart it from the beginning so that we're not. So there's 1, 2, 3, and so on. So that's a fun one, and you can connect in the Microbit Club bundle or the Microbit Go bundle. That's the individual one. There's a little connector here for a battery. And you can put it on your shoe and have it be a real step counter. Likewise, compass, radio communication, sunlight, emotion badge, beating heart. These are all some of the many, many examples that are available from Make It Code It. This is also a nice primer, especially if you're just focusing on the Cyberbot. This particular primer I like either in place of or in addition to the language primer that we had you go through as homework for the first day. And so there's lots in here to try. For example, here is reading the push buttons. Sorry, I know it's a little small. There we go. So here is one that displays the number of button presses that have been made. Anyway, there's lots to do in here. We've got hello world, images, buttons. That's the checking the touch sensor, music, random, which is a math. Well, it's basically a way to pick a random number for your script. So lots of good lessons here. There's also cyber.org. Cyber.org does curriculum for teachers in the United States. It's free to you. You can follow this link to sign up. I'll paste it into the okay, so that's the sign up page. And once you log into it, it's a Canvas environment. And there's more than just the Cyberbot and Microbit here. So we've got 3D printing for the classroom. There's advanced math for engineering and science. One of the ones that is Microbit only is coding fundamentals. And when you open it, it'll it's got a brief description, then it's got the lessons for block programming and the equivalent lessons for Python. Going back a couple of pages here, they also have Cyberbot material. in cyber literacy, I believe both 1 and 2. So here is cyber literacy. And then they actually have it for the Bobot robot, which is the original Parallax basic stamp robot, the Arduino Shield robot, and the Cyberbot. And so following the Cyberbot, you will see that they have lessons. So there's master notes for you, a PowerPoint, and a worksheet for the student for each of these chapters, or for many of the chapters. Some of them don't have the worksheet and are just strictly presenting, and then others have the worksheet. So that is an example of some of the material that's available through cyber.org. And they come through as PDFs. So here is what one of them looks like. And again, it's a free resource for you. I encourage you to go through and well, basically sign up, and then you can go through it and see if anything in here is something that you'd want to append to Cyberbot and Microbit lessons. Okay, and then we were talking about products earlier. So we already talked about how the 12-pack has the optional sensors. Now those optional sensors, again, are the ones that we talked about: the line follower, the TV remote, and the turret with the ultrasonic sensor on it. And then the stock kit is the one that we sent you for this course, which clearly has quite a few things you can do with it. Support, you know, I forgot to change this. The educator hotline, what are the hours for the educator hotline? I think it's 8 to 5 Pacific now. That's a little bit overstated. I noticed that, but forgot to update it. Sorry about that, folks. There's also education@parallax.com. As a teacher, we encourage you to use that if you're stuck and need to be contacted, or the educator hotline, especially if you're dealing with students who are, you know, all stuck on a particular thing and you're all scratching your head. Definitely call the educator hotline and/or email education@parallax.com. We also have a sales office, some forums, Facebook page. And there are also more pages on more social media resources on www.parallax.com. To see those, simply go to the very bottom of the page, and then you'll have our little logos for Facebook, Twitter, YouTube, and so on.
Andy, I have a question.
Yes.
For some of these courses, I know some people have been asking about putting them in their community college courses, but for students, do they have the option either like through cyber.org or through you guys to earn like some micro credentials or things like that besides just taking the course?
Not that I'm aware of. There may be some kind of certificate that students get if they attend a cyber.org workshop. I know that cyber.org used to do workshops during the summer with students. I don't know if they currently are. Yeah, this is primarily a resource for teachers to incorporate into their courses. We don't have certificates for students per se.
On the subject of certificates, I am presently preparing certificates for all y'all,
As is
showing
said in the
that you
South.
completed 8. Well, we were talking about cyber.org, so
Yeah.
they're based in Louisiana, that completed 8 hours of class and lab time. So those of you who stuck through all 3 days, I will be sending those out in case that is needed to show your powers that be.
Yeah, and thank you for that, Stephanie. And also this is the older basic stamp Bobot robot, and then the Arduino Shield bot, and both of these can be converted to a Cyberbot with this kit that's linked on this particular slide. these are really the only parts you need to switch over.
And that may look a little different with the RevC board.
Good point, Stephanie. Thank you.
The inventory will roll over sometime this summer, I'm sure.
Okay, so in the remaining 10 minutes, I'm going to whirlwind you through cybersecurity.
Really?
Yeah.
Hold on, everybody, buckle up. That's
it's a ton of material.
Yes. maybe just to hit the titles. we do have a couple of people waiting for troubleshooting assistance still.
Okay. All right. Good.
So, yeah. So 9 minutes. Go.
All right. There we go. First off, when you're doing cybersecurity and anything where you're using the terminal, it's good to set the power to full on your computer. If it's in battery saving mode, it may not run fast enough to support the communication back and forth with the terminal. Here's an example that I still want to have you try because it's kind of fun.
Okay.
Okay, I'll go ahead and paste this one in for everyone. Copy. And paste. Oh boy, just a minute. I need to paste it from here. Sorry. Let's do that again. Copy. Paste. Okay, get that second one where it's properly in. Oh no, they're both properly indented, it looks like. Yeah.
Joe says the first one works.
Okay, so don't do them both, but one or the other, they both work. And what you can do is flash this and then open serial. And it'll ask you to enter an integer and then enter an operator and then enter a second integer. And it'll give you the result. So that's more examples of what you can do with the terminal interactively. But what I really wanted to do was do the countdown one.
I think with just a couple minutes left, maybe just.
Yeah, okay, I'll tell you about it. So basically, there's a lot of background necessary for cybersecurity. So one of the things is simply how to interact with the terminal, both procedurally and in code. And so this is a code example from input and print for applications where you set up a countdown and then it asks you to enter the value to count down from and then the message afterwards. Now this is technically an application and it's going to come back later as something that is transmitted to another device and then protected using various cybersecurity techniques. More of the basics. We learn how each key on your keyboard corresponds with what's called a ASCII, ASCII code. And so for example, 66 is the letter B, 65 is the letter A, those are the capital versions, and then 97 would be lowercase a, for example. We also learn lots about strings. Strings of characters can be used to transmit information between microbits. And here's an example of a script that's deeper in one of the lessons where you actually see the ASCII code for each character. And you can modify the script to see what the ASCII code is going to be for different characters. And it goes on to allow you to print the entire ASCII chart using various various loop techniques like we did in the homework. String features is another thing, basically taking apart and putting strings back together, and more importantly, finding and accessing particular letters within the string. So as shown here, we're looking at a string named S, which is hello string. And then if we say that S is hello string, and then ask what is the sixth element in that string, counting from 0, it will give you back the letter S, because that's the sixth element.
You have a
Now
question.
that leads, go ahead.
Okay, the quick question was, so cybersecurity requires Microbit, not Cyberbot. Well, yes and no. Some of the cybersecurity focused lessons can be done with one microbit. Some require 2 microbit modules to talk to each other. And then some are applications that use those principles with a microbit and a cyberbot to interact with each other. And it could get quite elaborate where, you know, you're trying to hack control away from somebody's cyberbot. So.
Yeah, so we're starting with the basics right here. And for a lot of the basics, we're just using a microbit. But as Stephanie said, there are different variations of 1 or 2 microbits plus a cyberbot that are used later on. So here's an example of basic, we start doing encryption. And the most basic form of encryption is to basically say, well, if I want to send the letter H in hello, I'll go ahead and jump forward 5 characters, grab the letter M and send that. And then as long as my receiver knows that the letter M, that they have to jump 5 characters back, they can get the letter H. And that's where string manipulation comes in very much so, because these script encryptions have to say, okay, well, if I start with the letter M, that's the 12th letter in the alphabet. And if I can add 5 to that and then get back, I'm jumping ahead of myself. I can add 5 to that to get the letter R. Or I can subtract 5 from R to get back to the letter M, which was the original sent letter. So that's encryption and decryption. The Caesar cipher is the classical encryption decryption thing. And here's one where you can do whole words as opposed to just letters. And so hello, if our encryption key is 5, becomes MJQQT. If our encryption key is -5 and we give it MJQQT, we get hello back. And again, these are just, I'm cherry picking from a great deal of material that students work through. This one uses the entire ASCII chart for its encryption. So you can do stuff like characters, cases, and spaces, get something that's encrypted and then decrypt it and get back the original. So this right here is what we work to, and encryption as a fully functional thing that's used later. Okay, then students need a reason why to encrypt. Well, what better reason than having your chat eavesdropped on? So here is an example of 2 microbits having a chat with each other over radio. So although they're both plugged into my computer as I took this video, they are actually exchanging this data over radio. And this is part of cybersecurity radio basics. And the first thing that happens when you're on an open channel is that you'll end up seeing students trying to basically all kinds of hacking happens almost instantly when it's such an open channel, because students like to interfere with each other's conversations. It's fun for them. And so then loop back to the encryption that we just did. One thing that can be done to prevent, in this case, this is a sniffing attacks chapter. one thing that can be done is to use those encryption techniques that were used earlier so that the two microbits are having a conversation, but it's encrypted using the techniques that were introduced earlier so that a sniffing microbit only sees a bunch of crazy text. Dictionaries are part of are Python's way of putting together key value pairs. Key value pairs, every time you do an internet search, it becomes a key value pair. Search equals and then your search term. And key value pairs are fundamental for just about every web app that's communicating with a server somewhere. And so then we go into radio data, which is actual applications. And that's where the countdown is repeated again, but you enter your countdown information in one script, and then a receiving script does that. Okay, I know I'm over time. I'll get through this. I'm doing the maximum speed version of this. Exception handling is another thing in applications. Back when we did the calculations thing, if you did not enter the correct, if you tried to type in THREE instead of the number 3, the microbit would throw an exception and stop working. And so exception handling is important to keep your robotic applications running, even when they receive something over the radio that doesn't make sense. Now, one thing that's really fun is to do control over the keyboard. And if you have only one microbit, this keyboard control, you can still run the first example. And if you have a radio, if you have a second microbit, you can do the second example, which is keyboard control over the radio. That gives you yet another application that we want to protect using cybersecurity techniques. But there's also kind of a fun thing you can do when you have a classroom full of cyberbots. And that is have one microbit connected to your computer. It's right there. And we're typing in statements or commands for the microbits and the robots. So imagine a classroom full of robots where you have your microbit connected to the computer. Again, it's right in there. And he's typing in speed and duration information. And every time he hits enter to send one of those commands, all of the microbits on their radios hear that from the single microbit that's connected to the computer. So that's another one where there's data that the students are going to want to protect. They don't want somebody else eavesdropping. Like if you're having a contest, you could actually have the hackers and the cybersecurity protectors preventing the robot navigation from being interfered with or monitored. So that's control with the keyboard. And then there's also tilt control. This is a marvelous activity for, and again, something that it's over an open radio channel. And so it gives students the opportunity to okay, so here you can see the microbit being tilted, and there's a little pointer that's actually pointing in the direction it's being tilted. That pointer is being mirrored on the cyberbot. So as we tilt, we can see what's going on the cyberbot and that it's receiving the same tilt information that this microbit over here is transmitting over the radio. So that's our list of things that we want to protect with cybersecurity. Then we have a chapter on preventing sniffing attacks so that other student groups don't know where your robot is making its way through the maze and can't intercept you. And then there's also understanding how brute force attacks work so that you can use stronger encryption so as not to be found out. And not to be found out isn't the right way to put it, so that your encryption key is not found out. And then other students don't get access to your robotic application. And then this is what Stephanie mentioned earlier. It's a list of the different topics within cybersecurity and what's required. So on the prerequisites, yeah, you just need one microbit for all the prerequisites of cybersecurity. In the tutorials, radio basics and radio data takes 2 microbits. Encryption intro only needs 1. But then as you go further down, MB plus CB is microbit plus cyberbot, and that's in brute force attacks. And keyboard control, you need a cyberbot and an extra microbit. And this lists all of them. And also brute force attacks is published, even though it's not green, it is published. And I'm working on these two kind of as time permits.
Okay, you've only gone 6 minutes over.
I'm so sorry about that, folks. That was the whirlwind version of cybersecurity.
So
All right, so we have some tech support and hopefully some questions, comments, and etc. So I guess this would be the point where we stop recording.
all
And
right.
I say thanks for coming, everybody, and we'll keep going with your troubleshooting and also any questions, or if you want to try out some of those cybersecurity apps that I whirlwinded through, we can do those together as well. Thanks for coming, everyone.